All right. Hi, everybody. In this video, we are going to go over the solutions to Algebraic Problems 2. So let's get started. So a car accelerates from 13 meters per second to 25 meters per second in 6 seconds. Okay. So, right, your initial velocity is going to be 13 meters per second. Final velocity is 25 because it starts at 13 meters per second and it ends at 5. Tells us that the time is 6 seconds. And we would like to know our acceleration. So in looking at that, we have final velocity and time. The only equation that has final velocity and time is the Paul equation. So remember, write out the Paul equation like so, and then fill it in with the things that you know. So 25, 13 plus a times 6. You gotta subtract the 13 first. So subtract 13 from both sides. And you are going to get, let's see here, 15 minus an extra 3, 12 is equal to 6a. So divide by 6, divide by 6. And you're going to get that a is equal to 2 meters per second squared. So then it actually has a second question also in here. It says, how far did it travel in that amount of time? So we need an equation with x in it because we want to know. Now, how far did it go? You can use the John equation or you could use the Ringo equation. Both will work. I'm going to use the John equation, but realize Ringo equation worked just fine. So there we go. We write out the equation. Then we plug in our numbers. Let's assume that it starts from 0. Initial velocity is 13 this time, so make sure you put the 13 in there, not a 0. Time is 6 seconds. Acceleration is 2. So let's see. 13 times by 6 is going to give you 78. And 1/2 times by 2 times by 36. Well, 1/2 times by 2 is going to be 1. 6 squared is going to be 36. So that's going to give you 78 plus 36. So x is going to equal 114 meters. So there's the first one done. Second one, the car slows down from 23 meters per second to rest. Okay, so it was initially going 23 meters per second, slows down to rest, so your final velocity is 0. The distance you go is 85 meters. What was its acceleration? Okay, so that's what we're given, and we want to know the acceleration. Let's note that we're not given time, we're not asked for time, so that's a pretty good key that you need. The Ringo equation. Another key is the only one that has both the final velocity and the acceleration, or and the distance in it, is the Ringo equation. So that's going to be the Ringo equation. So b squared is equal to b naught squared. 2a delta x. I'm kind of thinking ahead. I'm expecting the acceleration to be negative because it's slowing down, and it was initially traveling at like positive 23 and it is slowing down. So that tells me that final velocity is 0. Initial velocity is 23. It's 2a. Okay, so 23 squared. 0 squared is obviously 0. 23 squared is 529. And 2 times by 85 is 170. Subtract the 225 or 29 to the other side. Divide by 170. And you're going to get that a is equal to negative 3.11 meters per second squared. Next, in coming to a stop, A truck leaves skid marks 92 meters long on the highway. Assuming an acceleration of -7 meters per second squared, estimate the speed of the car just before braking. Okay, so delta x is 92. Acceleration is -7. What else we got? If it's coming to a stop, that means the final velocity is 0, and we are looking for the initial velocity. So looking at that again, we have a final velocity and we have a distance. That really only happens if you're using the Ringo equation, so we're going to use the Ringo equation again. So there you go. Obviously, 0 squared is 0. 2 times by -7 times by 92 is going to give you -1288. Obviously, so next add the 1288 to the other side. So you're going to get 1288 is equal to V0 squared. So square root both sides. And you're going to get that V0 is equal to 35.9. Units on that are meters per second. So there we go. Moving on to the next one. So a model rocket rises with a constant acceleration to a height of 3.2 meters, at which its speed is 26 meters per second. So the model rocket, right, is going to start on the ground. So it doesn't tell us this, but you can assume that the initial velocity is 0 because, you're right, it presumably the rocket is at rest, not moving. We know the final velocity is 26. We know the delta x is 3.2, and we are looking for A. So another Ringo equation. So getting the use of it, okay? Let's see here. Final velocity 26, initial velocity 0. Right, and again, that's because we have the final velocity in the x and the position that we're going to end up using the Ringo equation. Leave the A in there, 3.2. 26 squared is going to give you 676. 0 squared is obviously going to give you 0. And 2 times by 3.2 is going to give you 6.4a. Then divide by 6.4. And you're going to get that a is equal to 105.6. Next, how much time does it take the rocket to reach this height? So we're looking for, we know all this information, plus we know A, and we're looking for T. So now we're looking for T. So there's a couple different ways you could do this. However, the easiest is probably to use the Paul equation. I mean, in theory, you could use either the Paul equation or the John equation. Just you'd have to do some square rooting if you did the Paul or the John equation. So it's just easier to use the John. Sorry, you would have to do some square rooting if you use the John equation. So it's just easier to use the Paul equation. So V is equal to V naught plus AT. We know our final speed is 26. We know our initial speed is 0. Acceleration is 105.6. And our time is what we are looking for. So 26 is equal to 105.6 t divided by 105.6. and you're going to get that t is equal to 0.25 seconds. And then lastly, find the height and speed of the rocket after 0.1 seconds. So now, right, we still know our initial velocity is 0. We still know that our acceleration is 105. We know that our time is 0.1 seconds. What else do we know? That's about it, right? So because it's a new time, it's not going to have gone 3.2 meters. Because it's a new time, it won't be going 26 meters. So this is the information that we know. Uh, First up, we would like to know the distance it goes, x. So let's assume that, right, it leaves the ground, and we'll call the ground x not equals 0, and we'll be looking for x up here. So x or delta x, it would be the same. Let's see here. The only one that has a position and a time in it is going to be the John equation. So x is equal to, again, remember you should be writing out your equations blank like so. And you might be disturbed by this really big acceleration of 105. Keep in mind it's a model rocket, right? So the model rockets accelerate pretty quickly. So that's not a big deal. Zeros, obviously, and 0 times by t are going to go away. Oh, shoot. Wait, hang on. I forgot to put in the time. Okay, there we go. It doesn't really matter, right? 0 times by 0.1 is 0. So you're just left with this side, 1/2 times by 105.6 times by 0.1. That's going to give you 0.53 meters as your answer. So that's your answer to the first question, which was what is the height? Next question is what is the speed? To do that, it's probably just easiest to use the Paul equation because we need to have a final velocity and we need it to have a time. So Paul equation is the one with the final velocity and the time. So again, final velocity is what we're looking for. Initial velocity is 0. And 105 times by 0.1 is 10.5. Well, really, I guess I would round to 10.6 meters per second. Cool. There you go. Well, I hope you find this useful. Thank you for watching, and